So I hotwired an AI music tool, and hopefully you can too. Okay, so I want to talk about this new tool I've been working on called MALT. So that stands for Manipulating Audio via Latent Timbre. Also working title, Manipulating Audio with Latent Trajectories. Same difference. So, the first bit of it makes sense, manipulating audio. We love manipulating audio. I make tons of music using samples. But I think the last two words, particularly this latent word, needs a bit of explaining. So I'm just going to quickly explain what that means. I'm going to do that by talking about normal distributions. Basically, say you have a population of people and you want to model their height, or you survey 100 people, you ask their height, and you plot it on a graph. So, you have a histogram, so you have the height on the bottom, and then you have how many people responded to each height point, or whichever. Then you're likely to get something like this. So this is a normal distribution, a Gaussian curve, basically models how statistically likely something is when you have a mean and then things around the mean. So you have something that's the average, and then you have around the average stuff that is less likely. So in this bit here, you have people that are shorter than average. You have the average height people, and then at the top you have the super tall people really above average. So we can kind of model sound in a similar way. So say you took 100 sounds and you had some aspect of their quality. So you had pitch or harshness or boominess or whichever. You might assume that they are normally distributed. So you have an average sound here, and then you have the less likely sounds, and also the less likely sounds on the other extreme here. And you could do that for a number of different dimensions, basically. So you could do that for the spectral centroid of a sound, the pitch of the sound, the loudness, something like boominess if you were doing perceptual ratings, etc. And when you take all of those normal distributions, so all of the statistical likelihoods of aspects of a sound, and you put them together, you get this complex statistical model called a latent space. And what that is basically like a high dimensional version of this graph. And we've been doing this for a really long time. So we've been modeling sounds in these complex spaces since the 70s. So here's a plot of some orchestral instruments from Gray and Gordon. Also, maybe earlier, 72, I think. There's work from David Vessel on timbre spaces. We've been trying to figure out this question of how sounds sound, like what the quality of a sound is, and how to organize those for a long time. And that only seems to really work in comparison to other sounds. So you take a bunch of sounds known as a corpus, so a corpus of samples, and then you compare them all to each other. And more recently, we've been able to use these sounds to generate new sounds. So you have your model, so you do an analysis section here. So you do your model of the sounds that you've got, and then you try and generate new sounds from that model, basically. So it's a probability distribution issue. And this thing in the middle is what makes it all work, what makes things speak to each other. So that's a latent space. So that is a set of, in this case, a set of statistical models that can generate and analyze new sounds. So you have sound in, modeling, sound out, basically. And this latent space is what I'm interested in, because that's the opportunity to mess with the sound. So you can organize this space in lots of different ways, and you can also generate music, or you can generate timbres from this space in lots of different ways. So one popular model at the moment is RAVE. And that uses a similar latent space architecture. So you analyze sounds and then you generate new sounds from that model. And then another popular model is After, which was recently used by Holly Herndon in her show at the Serpentine last year. We can go a step further, basically, and look at how sounds evolve over time. So that's where a trajectory comes in. So we can look at, on the left-hand side, we have this model of, a point in time, basically. So this is the path the sound takes. And you can see that its aspects actually change as time goes on. So as I move through the sound, maybe it becomes less harsh before coming around and becoming a bit harsher. So it's like a super average sound here, and then maybe a less likely sound here, and then back. So sounds evolve over time, the quality of sounds evolve over time, and that's where a trajectory can help us to model that. So we have a statistical model known as a latent space, and then within that we have encoded the nature of a sound over time. And this is super important because these models, these statistical models, are the basis, they're sort of the main building block for how we represent sounds in AI systems at the moment. Now, I'm sort of becoming like everyone else. When I hear the word AI or generative AI, I sort of like just cringe and shrink into myself a little bit. The state of the world and like all the stuff with Suno and pretty much everything Spotify does, and it's pretty dystopic, and it feels like creativity and the creative industry, and the whole creative economy is sort of under threat. That's a bit of a shame, because actually I think the history of generative AI in music is much longer than this present moment, and has been really fertile ground for artistic work. It's been really, really interesting in the past. So statistical modeling, rule-based systems, all these sort of like nascent fields in AI and music that was super duper interesting. And I'd love to make some more videos about that kind of stuff if people are interested, about the history of these systems and how artists sort of paved the way for that. But yeah, there's tons of creative applications for AI and statistical modeling in music. But right now everything seems to be really obsessed with LLMs and language and text to X, text to image, text to audio, text to whatever. And that's sort of, we're at the bottom of that well. It's not very interesting, is it? So as part of my PhD at the Centre of Digital Music, which is Queen Mary, University of London, and the Creative Computing Institute, which is the University of Arts London, I'm sort of creating systems like this with the aim of allowing us to use generative AI in creative ways again. So rather than outsourcing creativity to text models, and rather than sort of supplying these companies with more training data and training resources on the planet and all of this kinds of stuff. So all of my models are open source and low resource, so you should be able to run them on your own machine. And the idea is that they're just sort of creative playgrounds. So you, like I said before, you're able to hotwire AI systems. So you can take an existing system like RAVE or After or Stable Audio Open and use this system MALT to hotwire it with your own sounds and creatively manipulate a sample basically in the latent space. So by messing with the stats basically of the model. You can download it on my GitHub, load your own folder of samples, and then just like retrain a model and mess with it yourself. You just load a folder, choose whatever features you want, and retrain the model and let it rip. And then when you import a sample, you get your sample. So I like these umru sounds. They've been kind of fun to play with. They're sort of crazy. So like you've got this laser sound. I load that in. This strange laser sound. then I can mess with the sort of how the pitch responds and the spectral get these really strange textures. So yeah, that's the hope. Yeah, so get that, and if if you're interested, this is part of my PhD, so I'm doing longer studies with some compensation available for participants, and investigating how different types of modeling, different types of organization of these latent spaces can impact the ways in which we manipulate sounds. So do get in touch if that's of interest. Yeah, that's MALT. Right.